Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Now, my MakerBot works great, but another friend of mine gave me his old broken MakerBot. The magic smoke came out of it. It's been sitting up on the shelf, basically taking up space, but now Felix wants to repurpose it into something. Tell me more!
Yeah, I came up with an idea. I'm going to take it and put a USB microscope on it. So we can have a controlled precision microscope inspection station.
Oh yeah, that's cool. And you would know how far you've moved it since it's a CNC machine. So you could like look at, like, oh, that part is 10 millimeters from that part, or that pin is 3 millimeters from that pin. Right. That sounds pretty cool.
Yep.
So how are you going to do this? What are you going to use?
Well, I'm going to overhaul the MakerBot, then also update the electronics with a Beaglebone and a Replicape.
Oh yeah, the Replicape is the 3D printer CNC driver that you plug into a Beaglebone. Got it. And
then change the interface so I can control it with an old Atari joystick. And I got to learn about the Beaglebone Black and the Replicape, so we're going to get some help from Jason Kridner, the developer of the Beaglebone, and Elias Bakan, the developer of the Replicape.
Okay, and then you said you wanted me to make a mechanical focus adjust gantry? So we're basically going to remove the hot end stuff and replace it with something else.
Yep.
Okay, I'm going to go design that.
Thank you. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
So Felix wants to make this project using the Beaglebone Black. So we thought, who better to talk to than Jason Kridner, the father of the Beaglebone Black. How's it going?
Going great. Glad to hear from you guys.
Yeah, nice to see you.
So it sounds like you got a pretty cool project going, and you're using some pretty cool Cape hardware to help get it done.
Yeah, many years ago, I got the original Replicape from the Kickstarter or the Tindy or Etsy or wherever it came from. You said there's a newer one now, Jason?
There was a Rev B. The really cool thing is your timing's really interesting, because the guy that designed the Replicape, Elias Bakan, he's actually working on an all-in-one integrated board, and he hasn't started the crowdfunding campaign for that yet. But he's actually going to put the Beaglebone Black and the Replicape all into one board and call it Revolve, or the Replicape Evolved.
Yeah, you want to talk about what you want this project to do, Felix? And then, Jason, since you know so much about the Beaglebone Black, maybe you could help us think of ways, how can we leverage the power of the Beaglebone Black and the Replicape to achieve the best thing for Felix's project?
Yeah, all right, so I'm thinking we'd have a little joystick or some buttons to control the XYZ, and then also a knob to control the zoom. But what about having a display? What should we use for a display? And then also, should we connect to the HDMI or get a display off the GPIO? And then additionally, this is a USB microscope. How well is the Beaglebone going to be able to handle the USB microscope? What's the refresh rate going to be like on the screen?
Oh, you mean okay? So to use it to actually do the capture and the display.
Yeah.
If all you're doing is capture and redisplaying, I don't know exactly how the stream looks, but and what the resolution is. But I wouldn't think you'd have any sort of significant issue with keeping up with the frame capture on the USB camera and getting that to your display. Especially since I don't think you need you're going to be looking at static objects anyway. I don't think you need a super fast refresh rate. Just enough so that you're not going crazy as you're trying to zoom, but there's going to be a lot of lag. And you shouldn't have any significant problem. So you'll be able to take a 1080p monitor and get a nice big display of what you're seeing under the microscope over the micro HDMI. And you might be limited to a few frames per second, but I don't think it's going to be much of an issue for you. Probably not going to get 60 frames per second. You're probably going to get a few frames per second.
Another question, does the Beaglebone Black have a dedicated camera interface?
It doesn't, but a lot of people do camera interfaces over the PRUs. But because your microscope is USB, I mean, that's just using the USB is the right way to go.
Yeah. I have a question. Do the PRUs do the stepper control on the Replicape?
The Replicape firmware, so if you're using Elias's, what's it called, Marlin? Not Marlin, no, his version of Marlin, which is, it doesn't say what the firmware is there, but when you download his system firmware, he is using the peer used for driving the stepper motors.
Yeah,
so all the stepper motor pulses.
Yeah, I don't see any micros or anything on here. I mean, just drivers. So.
Oh yeah, for sure. He's using the peer used for doing the stepper motor.
Oh, I guess maybe we should mention, for the audience's sake, the Beaglebone Black has what, 2 32-bit microcontrollers on the die along with the ARM core, and so
3 technically.
Oh,
but,
3.
There's two programmable real-time units, which are those really ultra-low latency 32-bit RISC cores that run at 200 megahertz.
Yep.
There's also a Cortex M3 in there.
Oh, there is.
So which is also a 32-bit RISC core. Yeah. So there's also a Cortex M3 that you could use.
So in the case of
people are a lot more interested in the PRUs because they provide the lowest possible latency to I/O pins, right? So they have registers mapped directly to GPIO pins, and they can access the full peripheral memory as well. But they get that some 5 nanosecond updates on the I/O pins, which is pretty awesome.
Right, because on a normal 3D printer, you have like some sort of microcontroller doing all the stepping control, whereas if you have a Linux system, Linux is ultimately in charge, and sometimes it only gets around to the GPIO when it feels like it, but by separating that, you have the best of both worlds. And you have the same memory map too, so it's really easy to share information.
Yeah, exactly. They memory map, so they can both access the DDR. So essentially the path planning gets done by the ARM. And it generates like a pattern of the pulses that it wants to generate because it's an open loop control for stepper motors. And the PRUs just go and grab those out of DDR and generate the pulses in hard real time.
Okay.
I got another question on the line of operating systems. What OS would we want to put on the Beaglebone? I've read about and looked at and wanted to dabble with Linux CNC, but I don't know if would be adequate for this application.
x86? People usually put that on old computers, don't they?
Yeah, I mean Linux CNC is used on a lot of old computers and the parallel ports, right? They would actually hook up these old CNC mills to parallel ports and with old PCs and bit-bang controls out of them. But Linux CNC has been adapted to the Beaglebone. And a lot of people use Beaglebones as CNC controllers. That's actually a really popular application for Beaglebones, is essentially replacements for those computers to do CNC. So Linux CNC is an option, as is a fork of Linux CNC called Machine Kit.
All right, Jason, well, thanks for talking to us. Felix, I guess we've got a lot of work to do, and I'm definitely going to Midwest RepRap Fest. Jason will be there.
I'll see if I can make it.
Maybe Felix can go. Jesse Robinson's going to go.
Oh, cool.
Yeah. We can go all hang out in a county fair room in the middle of nowhere, and it'll be fun. All right, well, thanks for your advice, Jason.
Appreciate your time. All right, so Mr. Heckendorn made these awesome parts here for the gantry to house the microscope here, and also this stepper driver, or stepper motor. So, okay, let me see if I can figure out how to assemble this. It's like a jigsaw. All right, I gather that the microscope is gonna go into there somehow. Oh yeah, it'll go like that, huh? Cool. It's here. Oh, yes, okay. Well, I've got the gantry all put together and on the rails. It slides pretty good. It looks pretty awesome. I can turn this gear and it changes the focus on the camera. May need to make some small adjustments here, but it's working. Okay, now that I've got the gantry all pieced back together, we dug up this solar power supply. I'm going to use this power supply. I can cough up 24 volts at 5 amps. That should be plenty. Looks like I'm going to put this right down there. I found this piece of scrap wood that I'm going to use as a bracket. to hold it down. Basically what I'll do is I'll make some marks, and 4 marks on here, two on each side, and then put it back down in here, drill through this block, and then also drill through the board here. Then from the other side I'll put a screw through, and I'll attach this post. Then once I get those in place, I'll have holes on top here, so I'll put the screws here, and then they'll thread into these mounts, and it should hold it in there pretty snug. All right, so I'm gonna go ahead and do that now. Hiya! So hey, I was fooling around trying to get the dimensions of the bed figured out into this configuration file, and I created this configuration, this printer configuration, Replicape.cfg. In this configuration file, there's the system header. It has all this information. It says where to log errors or whatever, and machine type MakerBot Replicape is what we're calling it. I was having a little trouble here with the geometry, setting the offset, travel, the travel, and this bed compensation matrix. Whatever this does, whenever I have it uncommented, as in the code, everything just completely fails. So I just commented that out. I saw that somewhere, but there's no explanation for it, and I thought it might do something, but doesn't really seem to do much of anything other than this right here. The identity matrix is the default. That's the only information I have about it. I have no idea what it does other than make it not work. The geometry is a little tricky to figure out, and I wasn't quite able to get it to work right. So all I did to compensate for that, because I just want to get this project done and move on to the next part, I added 2 more limit switches, one for the X and then one for the Z. Now I'm kind of ignoring like the bed dimensions. I can just go over left as much as I want, and it'll just stop when it hits the limit switch. There, it hit the limit switch, now it's not going to go any further. Whereas before, the belt would keep spinning and it would kind of grind. Next, I'm going to figure out the device tree overlay to get this joystick working, and then it's going to be really cool. So stay tuned, or stay untuned, or drop in and tune out, or whatever you want to do.
Felix, what have you done to this old MakerBot? It looks like you've given it a new life.
Yeah, I tell you what, I brought it down from the shelf, put a Replicape in it, put a Beaglebone in there, attached a very modern
Atari joystick. And you're streaming the video through a computer?
Yeah, the video from the microscope is going into my computer here.
So it's not going into the Beaglebone, it's going to a separate computer?
Nope, not at this time.
All right. So the idea here is you can move the gantry head around and then focus it all with your controls. What does the button do? Does the button do anything? Yeah.
Oh, hey, check out this output that I got spitting from the code. So, like, press the button, it will stop the motors.
Okay.
And then it'll also switch the controls. So up and down, it boots when the program starts up and down. Let's just say is the Y.
Okay.
Is up, and
okay.
Up is Y plus.
Can I
down
try
is Y minus. Yeah, sure. And then left is X minus and right is X plus.
Why is it going in steps?
Because I'm not the greatest programmer on the planet.
Neither am I.
And this is the first time I ever programmed anything with G-code. So this is my first G-code program.
Oh, so you're probably sending it like a 5mm command.
That's exactly what I'm doing.
Yeah.
Okay, and then pressing the button. Here, let's take this out.
Does that toggle the mode?
Yeah. You press the button, toggles the mode, switches it into up and down, turns it to Z plus and Z minus.
Why did the light change?
Yeah, there's some kind of weird thing going on there, some kind of interference between the light and the motors.
Okay, I'm gonna toggle the mode.
All right, so now
should have some haptic feedback. And you're like beep 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 beep.
Yeah,
beep, beep,
I got the haptic in the.
Okay, so now the 2 axes of the joystick do something else.
Yep. So up down controls the Z, left right controls E, the extruder, but the extruder is then attached to the focus of the camera.
Oh, so basically that exchange. Can I see the screen?
Oh yeah, sure.
Yeah.
Look at that! You got it. Nice.
Nailed it.
Now switch your modes, and then
Just a second. I want to try.
Oh yeah. Oh, you really get in there. And then also there's that knob there. You can adjust the brightness of the camera.
Don't worry, I won't crash it. I've been doing CNC a long time.
Oh, yeah.
Is there a limit switch on the focus control?
There is not. There weren't enough. I didn't have any extra limits. Actually, I put a limit switch on both sides of the Z, both sides of the X, and both of the Y. And that was all limit switches.
All right.
There wasn't anything left for the...
The Z position looks like, you know, that obviously affects the focus as well, like how far you are from it. So that's pretty good focus. I'm going to switch modes, and now move around in X, Y. I mean, there is lag on the display, but I kind of like how it looks. You know, it's like, woo! Yeah, that's pretty cool. You know what's cool about this, Felix? If you had it zeroed out, since you're moving 5mm, if you zeroed in on a part on the center of the screen, and then you moved a set amount to the right or the left, you'd be like, hey, look, that part is however many millimeters away from the other one. You could use it as kind of a positioning system if you had like a bullseye in the middle, which is actually how a modern pick-and-place machine works.
Oh, like the Fudicial image?
Fudicial?
I think that's what it's called. Like the marking that's on a PCB that the optical recognition system looks for.
Ah, this reminds me of that scene in Blade Runner. Move 10 down.
What was that Red Dwarf scene?
Oh yeah, find a reflective surface. So what do you think about this project? Have you ever taken an old broken down 3D printer and fixed it up or turned it into something completely different? Let us know about it on the Element 14 community at element14.com/TBHS.
You can also go there's a little more about upcoming builds, episodes, and special events. We'll see you next time. See, I could be a European. I can look at something and guess how far it's moving, even though I'm an American and I don't like soccer. Okie dokie doo.
Ben, I was looking at our project list and I saw Yobo Ness on our list.
Okay, they have these Nintendo clones. They basically call them Nintendo on the chips. It's a little glop top on a circuit board and basically it clones a Nintendo system. Yobo is just a brand of little clone Nintendo consoles.
Oh, so what are we gonna do with it?
So I was thinking we could hack it up and use the parts to try to make a really small Nintendo clone. So you could take that around to show like MGC and say, oh, I'd better see if this Flintstones Dino Peak works and stick it in and then be like, I will still not buy it because it's too much money.